Hey, what up? Welcome to this new video. This one is paper 1 of May-June 2005. This is of course A-level math, paper 1. Now with that being said, let's move on to question number 1. Okay, so part 1 we have what? My curve is such that dy by dx is given by this. Okay, we have this information. We're given that the point 38 lies on the curve. This is a passing point. Find the equation of the curve. Again, equation of the curve means we have to find the value of y. And we must know y is equal to integration of dy by dx. So let's find this. That will be 2x squared minus 5 with respect to x. That will be 2 is 2. Increase the power by 1 and then divide by the power. Then minus 5x plus c, value is y. Now, we must find the value of c. To find the value of c, we must use the passing point, which is 38. This is the value of x, and this is the value of y. Replace back in your equation, you will have 8 is equal to 2 over 3 times 3 power 3 minus 5 times 3 plus c. Let's see what do we have. This will cancel out. This will be 2. That will be 8. 2 times 9 minus 15 plus c. 2 times 9 is minus 15, that should be 3. So 8 is 3 plus c. c will be 8 minus 3, and that should be 5. So finally, we can write down the equation. Y is equal to 2 over 3 x power 3 minus 5x plus 5. Okay, that will be the question in relation to integration. Now let's move on to the next. So we have to find the gradient of the curve y equal to this. So pretty easy. Gradient means we have to find dy by dx. So why is this? How can you find dy by dx? So in this case, we can find this by, there's a few methods. Obviously, here we can rewrite y as 12. Send this up, that will be x squared minus 4x power minus 1. Now dy by dx will be, we have to follow the same rules. First multiply by the power, that should be minus 12. Then we have to decrease the power by 1, that should be minus 2. And then multiply by d by dx of the value inside, that should be d by dx of x squared minus 4x. That will be minus 12 over the value of x squared minus 4x squared multiplied by 2x minus 4. Now here we don't want to find the value of dy by dx, but the gradient at the value of x equal to 3. We place the value back in the equation, you will have minus 12 over, that will be 3 squared is 9, minus 4 times 3 square, that should be 9. Then multiply by 2 times 3 minus 4, that should be 2. Divide by 3, that should be 4, that should be 3. That should be minus 8 over the value of 3. And this is the gradient of the curve at the point where x equal to 3. Let's move on to the next question. So here we have to show the equation this is equal to this can be expressed as tan theta is 3. So step by step. At first we have sine theta plus cos theta is equal to 2 times sine theta minus cos theta. Now here we can of course expand this. You'll have 2 sine theta minus 2 cos theta. We can send everything to one side, right? You will have what? So you have 2 sine theta minus this, you have sine theta remaining. And minus 2 minus 1 should be minus 3 cos theta is 0. Now we understand that tan theta is what? Tan theta by definition, it is sine theta over cos theta. So we have to divide by cos everywhere. Divide by cos theta, you will have tan theta minus 3 is 0. So finally tan theta is equal to 3, shown as required. Now part 2, hence means we have to use your answer from part 1, solve this equation for the values of theta between 0 and 360. So we know this is equal to tan theta is equal to 3, so we have to solve this equation. Now, from what we can see, tan theta is positive. It means it will be in the first quadrant. And in that third quadrant, this is simply the angle, and that will be 180 plus the angle. Because it is positive here, we can find the value of theta directly. That will be tan theta of 3. So we can find this using degrees here, obviously. Tan theta of 3, that should be 71.6 degrees, and the other angle will be 180 plus 71 plus 6, that should be 251.6. Okay, so finally we can write this down. Theta will be 71.6 and 251.6 degrees. Okay, and that will be your question for solving the equation to find the value of theta. Let's move on to the next question. So here we have to find the first 3 terms of this expansion in ascending powers of x. So pretty easy. First 3 terms, we begin with the expansion. That'll be first 6 choose 0. Here we have 2 and then minus x. Since this is 0, this will have to be 0 as well. 6 minus 0 is 6. That's my first term. Then continue. 6 choose 1. That'll be 2 minus x. We have 1 here. That'll have to be 1 here. 6 minus 1 is 5. And then third term, 6 choose 2. That'll have 2 here minus 1. That'll be 2 and 4 here. So let's see what do we have. 6 choose 0 is 1. That'll be 1 times 2 power 6 will be 64. And this will be 1. That will be 6. 32 will be minus x. And 6 choose 2. That will be 15. That will be 16 and x squared. 2 power 4 is 16. So let's see what else can we do. We can simplify. That will be 64 plus 6 times 32 will be minus 192x plus 15 times 16, that should be 240 x squared. So the first 3 term will be 64 minus 192x plus 240 x squared. Now for part 2, we had to find the value of k, for which there's no term in x squared for this expansion. So now we have to expand 1 plus kx multiplied by 2 minus x power 6. Now we have something here. It tells you that we have no term in x squared, which means the term in x squared is 0x squared. Using this, we have to find the value of k. Now how would you expand this? It is simply 1 times 2 minus x power 6 plus kx times 2 minus x power 6. Now for the first one is 1 times 64 minus 192 x plus 240 x squared plus kx times 64 minus 192 x plus 240 x squared from part 1, right? Now here in this question we only care about the term in x squared. So 1 times this one, 240 x squared plus kx multiplied by this one, 192x, because we only care about x squared. This will give you 240x squared plus minus 192k x squared. We know if you factorize, you will have 240 minus 192k, that will be x squared. And we know this is a term in x squared, and here we have no term in x squared, which means this have to be 0. So let's equate that to 0 and see what happens. That'll be 192k have to be 240. So k will be 240 divided by 192. That should be 1.25 for your value of k. Okay, and that will be a question to finding k for this binomial expansion. Now let's move on to the next question. The diagram shows a rhombus A, B, C, D. The points B and D have the points coordinates 2, 10, and 6, 2, as we can see right here. Now, we know the midpoint of BD is M, right here, so we can find M pretty easily. M is the midpoint. That will be x1 plus x2, that will be 8 divided by 2 will be 4. y1 plus y2, that will be 12 divided by 2 will be 6. So this is the midpoint M of the rhombus. Okay, so now next thing we have to find the point A. How can you find A? As you can see, A is on the x-axis. On the x-axis, we know the value of y will be 0. But anyways, the main thing here we have to understand is that if you were to join the points A, M, C, they are a straight line at 90 degrees to the line BD. So we have to first find the equation of the line AM. So to find the line AM, we have to find its gradient, and as we can see, we can first find the gradient of BD. That will be simply y2 minus y1 over x2 minus x1. That should be minus 8 over 4, and that will be minus 2. From this, we can derive the gradient of AM will be the value of plus half. Now we have the point, so we have the gradient of AM, we have the passing point of M, which is 4, 6. We can find the equation. That will be y minus 6 over x minus 4 have to be half. Cross multiply, you will have 2y minus 12 have to be x minus 4. 2y has to be x minus 4 plus 12. So you have 2y have to be x plus 8. So this will be the equation of AM. Now we have to find this point of intersection. On the x-axis, the value of y will be 0. That will be x plus 8. So x will be minus 8. So the point A will be minus 8 and 0. This is minus 8. Now to find the point C is pretty easy as well. We just have to use vector displacement. For example, from the point A to go to M, we have to, because we understand that AM is the same length as MC. So M going to M, this is the value of 4 here, and the height is 6. So we have to move 12 and 6. So A to go to M, move 12 and 6. So same thing, M to go to C, we have to move 12 and 6. So by vector displacement, 12 and 6. Now by comparison, so here we have the point M is given to you by 4, 6, so move 12, that will be 16. 6 plus 6, that will be 12. So this is the point C by vector displacement will be 16, 12. And that will be the question in regards to geometry. Now for part 6, a geometric progression has 6 terms. Okay, so the number of terms is 6. Now we know we have a geometric progression. So we know the n term, for example, is going to be a r n minus 1. And the sum to infinity have to be a over 1 minus r. So that's how we can write for now. The first term is going to be 192, good to know. And the common ratio is 1.5. Okay, these are the given information. Now, we have another progression. An arithmetic progression has 21 terms. Now we know for AP, the n term is given to you by a plus n minus 1 times d. Sum of the first n term is half n, and then we have 2a plus n minus 1 d. Okay, so we have 21 terms, and the common difference d is going to be 1.5. Okay, now given the sum of the terms in the geometric progression is equal, they're the same, to the sum of all the terms in the arithmetic progression, find the first and last term of the arithmetic progression. Okay, so we have to find a and the last term, which is the 21st term of the arithmetic progression. So one by one. So we know the sum of all the terms, so of the 6 terms is equal to the sum of the 21 terms for the AP. So one by one here we have to replace for this one for the GP, and this is for the AP. So here we have sum of the first 6 term. So we have to know this formula here. Again, this is given to you for geometric. Let me write this down. It is sum of the first n term for geometric is a. Here we have r is more than 1, so we can put r here, no big deal. That will be this, power n minus 1 over 1.5 minus 1. So sum of the first 6 term, that should be a is the first term is 192. 1.5 is the common ratio, n is 6 minus 1 over 1.5 minus 1 is 0.5. That should be equal to the sum of the first 21 terms. Let's see what do we have here. That will be half. N is 21. 2a. 2 times a we don't know. Plus n minus 1. N is 21 minus 1 is 20. Times d is the difference. I think we know this. It is 1.5. So I will replace it afterwards. For now, we can just try to solve this. So here we have divided by 0.5, which is 192 divided by 0.5 should be 384. Have 1.5 minus 1. Here we have half, 21. And here we have 2a and plus, so 20 times 1.5 should be 30. So we can multiply by 2. Over here you will have what? 384 times 2, that should be 768. Then 1.5 minus 1, that should be 21. Then 2a plus 30. So 2a plus 30 will be 768 divided by 21 times 1.5 power 6 minus 1. And then 2a will be all this 768 to 1.5 this minus 30. So answer divided by 21 should be this value times, so let me just do everything, 1.5 power 6 minus 1 is this, multiplied by 768 divided by 21 minus 30, that will be 350. So 2a will be 350. So a will be divided by 2, that should be 175. So we have found the value of a to be this. Now moving on, we can find the value of the first term, a, is 175, and the last term is the 21st term. So 21st term, that will be using the formula, of course, that will be a plus n minus 1 will be 20 times d, which is 1.5 for the common difference. That will be 175 plus 20 times 1.5, that should be 205 for the last term. So first term was found to be 175 and last term was 205. Again, last term was the 21st term because we have 21 term in the progression. And that will be your question in regards to series. The function f is defined by f of x is equal to this for the values of x between 0 and 360. Now find the range of f, so pretty easy. So 3 is a constant, 2 is a constant, so only this changes. So now we know sin x is only between the values of minus 1 and 1. So let's take the minimum value. So 3 minus 1, that should be, so when sin x is equal to minus 1, we have f of x will be 3 minus 2 minus 1, that should be 3 plus 2, and that will be 5. And then what if sine of x is equal to 1 for this value? That will be f of x will be 3 minus 2 times 1, 3 minus 2, that should be 1. So the range is between those two values, so we can write the range of f, we can write f or y is between the value of 1 and 5 for part 1. Now for part 2, we have to sketch the graph of this. Now we understand y is equal to 3 sine 2, so 3 minus 2 sine x. Now again, this is the graph for the trigonometry function. So we have the x values and the y values. So again, the advice is the same as always. Whenever you have to draw a trigonometric graph, we have to use a table of values. So we begin with 0. Now the interval will be what? The interval will be, because the coefficient here is 1, we'll take 90, divide by the coefficient, that will be 90. Now the reason why I choose this is because I want to work with exact values, right? So move on, that will be 90, that will be plus 90, that will be 180, that will be 270, and finally 360. Let's find the corresponding values of y. So first one, 3 minus 2 sine 0, that will be 3. Then we have 3 minus 2 sine of 90, that should be 1. Then 3 minus 2 sine of 180, that should be 3. 3 minus 2 sine of 270, that should be 5. And finally 360, 3 minus 2 sine of 360, that should be 3. Okay, so here we can sketch the graph. Again, it is best to use a ruler to kind of draw your axis, right? And that will be my y-axis. This is the x-axis. I can mark this approximately. Okay, that will be 0, 90, 180, 270, and 360. Now the value of, let's say 1 is here, let's say 3 is here, and 5 is here. So 1, 3, 5. That will be y, and that will be x. So first one, 0, 3 will be right here. 91 will be somewhere over here. 183 somewhere over here. Then we have 270 will be 5. That will be somewhere over here. And then we have this, that should be 3, somewhere over here. Let's try our best to join them by a smooth curve. That should be something like this. Right. Again, it is only a sketch. It doesn't need to be exact. But finally, you have to label your graph as y equal to 3 minus 2 sin x. That will be part 2 of the question. Now for part 3, we have what? We have another function now. Function g is defined by this. Same thing again, where it is between 0 and a, where a is the constant to be found. Great. Now, state the largest value of a for which g has an inverse. So we have to understand, for g to have an inverse, it has to be a one-to-one function. So for example here, again, you don't have to draw this. So for it to be a one-to-one function, if we draw a line, for example, we must have only one solution. Here we have 2 points of intersection. The only way to make this become a one-to-one function, we have to restrict the values we can take for x. For example, if you stop the value of x right here, the value of a to be 90, you will have only this part. Now when you have this part, when you draw your line, we have only 1 point and 1 point. This is how we can make this become a one-to-one function. So a will have to be, the largest value of a have to be 90 degrees. That's the largest value of a. Now, for which it has an inverse, obviously we know that only a one-to-one function can have an inverse. That's why we have to show this. And then we realize that because the x values begin from 0, so we have to look from 0, keep going on until 90, we can have an inverse, because from this point to this point, it has a one-to-one function. That will be your question for part 3. Now for part 4, when a has this value, which is 90, obtain an expression for inverse. So let's find out. So we know that g of x is equal to 3 minus 2 sin x. First thing first, let y equal to 3 minus 2 sin x. Now sin x will be what? Y minus 3 divided by minus 2, right? We can write 3 minus y over 2. Same thing. Now x will be sin inverse of 3 minus y over 2. Now finally, we can write that in terms of x. So g inverse of x, that will be sin inverse 3 minus x over 2. So that will be part 4 of your question, to find an inverse for g of x. Let's move on to the next question. So in the diagram, we have ABC is a semicircle. As you can see here, we have a semicircle. Center is O and radius is 9. This is the radius, and the radius 9 over here. Now, the line BD is perpendicular to the diameter AC. This is a vertical line, as you can see here. Now, the angle AOB is 2.4, as we can see as well over here. Now, part 1, we have to show the BD is this, correct, to 3SF. Now, where's BD? It is this one. So pretty easy. We can first find the angle over here. This will be 180 minus this one, radians. Now, once we know the angle, we know this is a triangle, this is a right angle triangle, we can use SOHCAHTOA to find the value of BD. So this is my H side. I'm trying to find my opposite side. We have to use sine. Sine of the angle is equal to opposite side BD over the value of 9. So BD have to be 9 sine of, Here we have to use radians, obviously. Pi minus 2.4. That should be 6.079, which is 6.08, correct to 3SF, shown as required. Okay, that is part 1 done. Now part 2, we have to find the perimeter of the region. Again, perimeter is defined by the distance around the object. Let's find this one by one. So P is equal to, first we have to find this, BD, it is 6.08, plus this one, we don't know, OD, plus this one, we know it is 9, and this one, we have to find AB. So let's first find the length of AB. AB is the length of arc of radius 9 and angle this. So AB, pretty easy, that should be r theta, 9 times the angle. So 9 times 2.4, that should be 21.6. Now we have to find the length of OD. OD pretty easy as well. We can use the Pythagoras theorem now because we know the two sides of this right angle triangle. So it will be root of 9 square minus 6.08 square. So 9 square minus 6.08 square, that will be 6.643SF. So let's add everything. We have 6.08 plus your answer plus 9 plus 21.6. That should be 43. So the value of P here will be 43.3, correct to 3SF for your perimeter. Again, the concept behind is pretty easy. It is just the distance around, and then we have to form an equation. P is equal to this, plus this, plus this, and plus this. We have to find the unknown and then add them together. Now for part 3, we have to find the area of the shaded region. So as you can see, it will be two parts. One will be this one, and it will be this one, the triangle. So for part 1, pretty easy. It is the area of sector. We have to know the formula for this. It is half r square theta is the angle right here. Half is half, r square is 9 square, angle is 2.4. That's the first part. So half times 81 times 2.4, that should be 97.2. Now for part 2, we have to find the area of the triangle. It's a right angle triangle, that will be half times base. OD is given by 6.64, and times height. Height is 6.08. Again, the reason why we can do this is because it is a right angle triangle. Half times base times the perpendicular height. That will be 20.1856. So the area will be 97.2 plus answer, that should be 117.3856. That should be 1.117, correct to 3SF. That will be centimeters square. So this will be a question in relation to circular measure for this paper. Let's move on to the next question. So a curve have equation y equals to 4 over root of x. Now we realize that we can rewrite this as 4x power minus half. Right. Now what else? Part 1. The normal to the curve at the point 4,2, this is the x value and the y value, meets the x-axis at P and the y-axis at Q. Now find the length between P and Q. So we first have to find the points P and Q. Now, to find the points P and Q, we have to find the equation of the normal. Now we understand the normal is a straight line, so you have to find the gradient of the normal. Now as always, the gradient of the normal and the gradient of the tangent, they are related. We understand that, for example, here we have a curve. Let's say the curve is in this shape, and the point is here, 4,2. The normal will be a line in this direction, for example, and the tangent will be a line at 90 degrees to, I don't think it's a good drawing, but you get the idea. This is their relationship. So we know that gradient of normal multiplied by gradient of tangent has to be minus 1. Okay, so using that relationship, we can find the gradient of the normal. So one by one, we know this is simply dy by dx. So let's find dy by dx. It is going to be equal to, first thing first, multiply by minus half. Then we have 4 here. Minus 1, that will be minus 3 over 2. That should be minus 2 x over value of 3 over 2. This is dy by dx. Now, we have to find this value at x equal to the value of 4. That should be 2 over 4 power 1.5 should be 8. That should be 1 over 4. Here is minus 1 over 4. Now from this we can derive the gradient of normal have to be the value of 4. Now we have 4, we have a passing point 4, 2. We can find the equation of the normal, right? That will be the x value and the y value. So y minus 2 over x minus 4 has to be the value of 4. Now cross multiply, you will have y minus 2 have to be 4x minus 16. Now we have to simplify y have to be 4x plus 14 for the equation of the normal. That is part 1 of the question. Now moving on, we have to find the points P and Q. Now the point P is on the x-axis. We know that on the x-axis the y value have to be 0. Replace, you have 0 here. 4x plus 14. X has to be minus 14 over 4. Let's see what does that give me. Minus 3.5. So the point P has to be minus 3.5 and 0. Now moving on to the next one. We have on the y-axis, the value of x have to be 0. Replace, you will have y equal to 14. So the passing point will be 0 and 14. That will be the point Q. P and Q, we have found the values. Now we have to find the length of PQ. Pretty easy. Just use your formula for that. The length of PQ will be root of x2 minus x1 will be 3.5 square plus 14 minus 0 will be 14. Then we have to square the value as well. That will be 3.5 square plus 14 square. Root of that will be 14.4 units, correct to 3SF. That will be question part 1. Now for part 2, we have to find the area enclosed by the curve, the x-axis, and the line this and this. So pretty easy. The main idea here is that if you think we will have a curve, right? The shape will be somewhat like this. And we have two lines here, x equal to 1, x equal to 2, right? Now we have to try to find the area enclosed, which is area under curve between those two limits. So we have to find this by using integration. So we have 2 here and 1 here. And the equation is 4x power minus half with respect to dx. Now 4 is only a multiple. We can leave this outside. And we have to first increase the power by 1. That will be half. Then divide by the power. Then limits will be 2 and 1. And finally, there have to be 8x power half to 1. Right. Now let's move on with the questions. So here we have what? 8 outside, and here we have 2 power half is root of 2 minus 1. Let's see what does that give me. So root 2 minus 1 times 8, that should be 3.31 units square, correct to 3SF. Again, let's check. The equation of the curve is this, which is 4x power minus half. Integration of the curve will be 4x power minus half. Take out 4 outside, it is only a multiple. Then we have to increase the power by 1, it will be half divided by half will be 8, and then step by step between those limits you will have this as your answer. And that will be a question in relation to integration, and I think a bit of algebra as well. Now let's move on to question number 10. The equation of a curve is given to you by this. Okay, show the whole curve lies above the x-axis. So how can we show this? So we can complete the squares to see if it is always positive, right? So let's do this. So complete square for this curve. So at first we have this. Leave some space for plus 4, because here it is 1, we can proceed to the next step. So we have x squared. Here we have minus 3x. Now we have to add something. Add something will be the value here, which is 3 over 2 square. Now we have plus 4. When you add something, you have to minus the same value as well, so you don't change the equation. So here you have x minus 1.5, and here we have square, and here we have 4 minus 1.5 square. That should be 1.75. So we have shown that this is always going to be more equal to 0. This is 1.75. Now if the shape of the curve will be something like this. This is the axis, This is x and y. Now as you can see, we can show that this is the minimum value. It should be somewhere over here at the point of 1.5. This is the 1.5, this is 1.75. So the shape is something like this, right? Your curve is a minimum curve. It will be always above this. So you can show this equation, and you can see by this it is always going to be more than 0. Or you can show the minimum point is 1.5 and 1.75, because it always have to be more than this. You have shown that it will be above the x-axis. Now for part 2, we have to find the set of values for x for which this is a decreasing function. So let's do that. So let's find the set of values of x. So decreasing function, it is dy by dx have to be less than 0 for it to be a decreasing function. Now dy by dx is what? It is 2x minus 3 less than 0. X will have to be less than 3 over 2, which is 1.5. So x is less than 3 over 2, sorry, 1.5 for the set of values of x for it to be a decreasing function of x. That is part 2 of the question. Now for part 3, we have a line which is this, where k is a constant. Now part 3, in the case where k is this, which is y equal to minus 2x plus k, find the point of intersection between the line and the curve. So we have the line now is 6 minus 2x, and the curve is y equal to x squared minus 3x plus 4. Now here we have y and here we have y. Replace, you have 6 minus 2x. That should be x squared minus 3x plus 4. Let's send everything to one side. That will be x squared minus 3x plus 2x plus 4 minus 6. That will be x squared minus x minus 2 have to be 0. So let's try to factorize. Let's see what happens. That will be x, that will be 2 times 1. We need minus 1, have to be minus 2 plus 1. Or you can solve by using your formula as well, up to you. X is 2 and x have to be minus 1. So which means y have to be 6 minus 2 times 2, that should be 2. Or y should be 6 minus 2 times minus 1, that should be 6 plus 2, that should be 8. The points will be 2, 2, and minus 1, 8. Let's move on to the last one. We have to find the value of k for which the line is a tangent to the curve. Now, tangent to the curve means it meets the line at only one point. That's what it means. It means that it has only one solution. So pretty easy. Here we have y equal to k minus 2x and y equal to x squared minus 3x plus 4. Solve. On one side you have this, and on the other side you will have this, right? And then you will have what? X squared minus 3x plus 2x plus 4 minus k have to be 0. Now we have x squared minus x plus 4 minus k. Now this is value of a, value of b, and c. So because it is a tangent to the curve, we realize that b squared minus 4ac have to be 1. Again, this indicates that it meets the curve at only one point, which means it has only one solution. If you have only one solution, we have to use this, right? B squared is 1 minus 4 times 1 times c. So you have 1 minus 16 plus 4k have to be 0. So 4k have to be 15, k have to be 15 divided by 4, that should be 3.75. Okay, and that will be your value for k for which the line is a tangent to the curve. Let's move on to the next question. So relating to a point O, the position vectors of A and B given to you by this. So pretty cool. We know that OA is the same thing as 2, 3, minus 1. And OB is the same thing as 4, minus 3, 2. Part 1. We have to use scalar product to find the angle AOB, correct, to the nearest degree. So now again from O, we can go to A, or going to B. So you have to be OA times OB should be magnitude of OA, magnitude of OB, and then cos of the angle AOB. So here we have the two vectors over here for scalar product. Now OA is 2, 3 minus 1. OB is 4 minus 3, 2. Now the length of OA is root of 2 square plus 3 square plus 1 square. That should be 14. And this one should be 16 plus 9 plus 4. That should be 29. Cos of the angle. Now simplify this. 8 minus 9 minus 2. That should be minus 3. Divided by 14 times 29 should be root of 406. That will be cos of the angle O. From this we can find the value of the angle AOB, that will be cos inverse of this. Let's see what do we have. So minus 3 divided by root of answer should be this. Cos inverse of that should be, so here we have to use degrees, so cos inverse of minus 3 divided by root 406. That should be 98.56, which is 99 degrees. Correct to the nearest degree. That is part 1 of the question. Now for part 2, we have to find the unit vector in the direction of AB. So first thing first, we have to find AB. AB is defined by OB minus OA. Again, always we have to look at the second one first. So AB will be OB minus OA. Now from this, OB will be 4 minus 3, 2. OA is 2, 3 minus 1. So that will give you what? 4 minus 2 is 2. Minus 3 is minus 6. That should be 3. Right. Now unit vector we have to divide by the magnitude. So what is the magnitude of AB? That should be root of 4 plus 36 plus 9. We have to square those values. 4, 36 and 9. So 4 plus 36 plus 9, it should be 49. And that is 7. So the unit vector in the direction of AB will be, AB is 2i minus 6j plus 3k divided by 7. That should be the unit vector in the direction of AB. Now for part 3, the point C is such that we have OC is this, where P we don't know, right? Given the length of AB and AC are equal, find the possible values of P. Now the length of AB, as we have seen here, it is 7. Now we also know the length of AC have to be 7 as well, according to the question. Now how would you find this? By definition, AC have to be OC, again take the second one first, minus OA. OC given to you by 0, 6, P, minus OA given to you by 2, 3 minus 1. That should be minus 2, 3, and P plus 1. Now to find the length, we have to use the formula we know, that is 4 plus 9 plus P plus 1 square, have to be 7, same length as AB. Square both sides, you will have 13 plus this, have to be 49, so P plus 1 square have to be 49 minus 13, that should be 36, which means P plus 1 have to be plus minus 6. Now from this, P has to equal to minus 1 plus minus 6, so P can be minus 1 plus 6, or P can be minus 1 minus 6. That could be 5 or could be minus 7. So these two are the possible values of P for when their length are equal. Now this one was a question in relation to vectors, and that was the last question of this paper. Thank you for watching. I will see you soon.